Hello, everyone. Welcome to Feedstuffs 365. I'm Sarah Muirhead. A wide range of greenhouse gas emission estimates have been observed for soybeans and soybean meals. Estimates vary due to differences in spatial space, land use changes, farming practices, and exclusion of biogenetic carbon. So lots of variation there. Joining us today to talk about this global variation in life cycle greenhouse gas emissions for soybeans and soybean meal are Dr. Gerald Shurson of University of Minnesota, Department of Animal Science, and Dr. Nate Springer of the University of Minnesota Institute on the Environment. Welcome to you both. Thank you for being here with us today.
Well, thanks, Sarah.
Yeah, thanks.
Before we get into today's discussion, a reminder, if you have any questions, feel free to post those there in the chat area on your screen. If you're joining us from social media, you can put your questions right in those channels and we can see those. So during the last few years, we've conducted several Feedstuffs 365 webinars on soybean meal, and there's been a lot of discussion about the nutritional value of soybean meal in swine diets. Also, a lot of talk about the benefits of feeding high soybean meal diets to PRRS infected pigs. There's not, however, been much discussion on the environmental impacts of using soybean meal in swine diets. So a few years ago, you and I talked about that on a Feedstuffs 365 webinar. We looked at some research that your team was doing, that you had published on the environmental impact of feeding programs in different pork production regions in the U.S. Why don't you remind us a little bit on the highlights of that study and how it relates to new publications that you're working on? And let's explore that a little bit, and then we can move further into our discussion.
Yeah, I'd be happy to. And thanks again, Sarah, for having us on. It's always a pleasure to join the audience on a Feedstuffs 365. Yeah, back in 2022, our team published, I think, one of our foundational studies that kind of got us involved in a lot more life cycle assessments of feeding programs and feed ingredients for a lot of our different commodity groups, and probably to put the main focus of our discussion today, provide a little bit of background, is that we used our Foods Cube model to estimate the greenhouse gas emissions, land use, and water use of some common ingredients: corn, soybean meal, DDGS, and a source of thermally processed food waste in swine grower finisher feeding programs in essentially three different major pig production regions of the U.S. And as shown in this slide, we chose these regions, Midwest in particular, is where most of the pigs are produced and slaughtered, along with the Mid-Atlantic and the Southwest regions of the U.S. And combined, these three regions make up about 97% of the locations where the pigs are produced in the U.S. And part of what we were interested in this earlier study is the amount of variation in greenhouse gas emissions and land use and water use footprints that existed in pig production, which was based on the kinds of feed ingredients and feeding programs we were using. And this is important because feed and manure have the greatest effects on environmental impacts of animal production in general, pork production in this case specifically. And we used our Foods Cube model to calculate estimates for greenhouse gas emissions, land use, water use for the sources of corn, soybean meal, DDGS, and food waste that we used in these three different pork production regions. And basically, we wanted to know how the geographic variation in environmental impacts of the sources of these ingredients affected the environmental footprint of pork production in these different regions when they were used to formulate grower-finisher pig diets. And so the results of using our Foods Cube model and modeling these environmental impacts, and by the way, in our Foods Cube model, we are pretty unique and pretty proud of the fact that we are modeling county level data, unlike what's often used at the state level or the national level for other environmental impact estimates. And so having that kind of granularity really helps us dig into the details of the impacts more at the local level. And so the results that we found from modeling these impacts um, showed that, you know, among the four ingredients, soybean meal had the greatest greenhouse gas emissions in the mid-Atlantic and Southwest regions, and the second highest greenhouse gas emissions impact in the Midwest, where it was slightly less than DDGS. And so what we learned, obviously, from this study is that soybean meal also had the greatest impact on land use among the four ingredients. We were interested in land use estimates for feed ingredients because it's one of the main contributors to greenhouse gas emissions, especially for soybean and corn production. And so to bring this all together, when we use those estimates for those different feed ingredients in formulated diets for multi-phase grower finisher feeding programs, which included, you know, typical corn, soybean meal based diets, kind of as our control or our baseline, and then corn, soy, 15% DDGS diets. And then we had a corn, soybean meal, 8.5% food waste diets. And then also we had a low crude protein amino acid supplemented set of diets. And we compared these environmental impact estimates using those different combinations of ingredients, and showed that pigs produced in the Midwest have the lowest greenhouse gas emissions per market hog, and that the corn, soybean meal, and corn, soybean meal DDGS feeding programs had the greatest greenhouse gas emissions when we combine the feed and manure estimates compared to feeding programs that focus more on using some food waste or the low protein amino acid supplemented diets in these different regions. And so what's interesting in all of this, and I hope that the theme is coming through, that we're dealing with a lot of variation. There was a wide range in greenhouse gas emissions within and across pork production regions, as shown in this slide, where greenhouse gas emissions, and by the way, they're usually expressed as kilograms of carbon dioxide equivalents, because CO2 is a greenhouse gas that's used as a standard. And as you can see in this slide, our lowest estimates for on a per market hog basis using these types of diets was 266 kilograms of CO2 equivalent per market hog, up to as much as 570 kilograms of CO2 equivalent. The point of all of this is that there's a lot of variation, and the estimates that we use for different feed ingredients, for different environmental impact indicators like greenhouse gas emissions, are really important if we're going to have accurate assessments that we can use to meet sustainability targets in supply chains and a variety of other things. And so because there's an increasing trend to use life cycle assessment data as constraints in formulating low environmental impact swine diets, we were wondering how much variation in greenhouse gas emissions for soybean meal was due to farming practices and yields versus how much can be attributed to differences in methodology used by different researchers. And that really kind of led us to the study that we're going to be talking about today. And we wanted to know not only for the US estimates, but how do these estimates compare with soybean meal and soybeans produced in other countries?
Great job of giving us that initial background there, Jerry. Let's now talk about the review, the article that your team published, which was explaining global variation in life cycle greenhouse gas emissions from soybeans and soybean meal. So go ahead and talk to us about this recent review and remind us of the definition, of course, of what life cycle assessment is and how that's used when it comes to formulating animal diets. And of course, there is a link there in the chat to this study if you're interested.
Yeah, life cycle assessment, for people that may not be familiar with it, it's a scientific method that is being used pretty broadly across the globe, actually, to estimate the total environmental impact of a product or a material ranging from the initial stages of production to its final disposal. So hence the term life cycle. And it's been widely used as a method to provide quantitative estimates on environmental impacts of feed ingredients, for example, such as greenhouse gas emissions, which I've been talking about so far. And these environmental impacts, there's a large database called the GFLI database for a variety of feed ingredients available around the world that has 20 different environmental impact indicators, including greenhouse gas emissions. And so these estimates can be used as constraints when we formulate diets for not only pigs, but other livestock and poultry species to estimate the environmental impact of animal production. But I should point out that even though there are standard methodologies that we use to guide the calculations of LCAs, different researchers use different methodologies, which can result in differences in calculated estimates from different studies. And so because corn and soybean meal diets have become kind of a standard that we use to compare these environmental impacts of swine diets relative to other alternative ingredients being used, we wanted to conduct this review of soybean and soybean meal LCA literature to analyze some of the differences in methodology that were used to calculate some of these LCA greenhouse gas estimates, summarize some of the ranges in results, and explain some of the drivers of what causes some of the differences, or what are the contributions to the variation that we see in these estimates for soybeans and soybean meal across studies and across countries. And probably most importantly, we wanted to be able to take this information and provide recommendations for the next steps to improve LCA determinations of soybeans and soybean meal for future groups that work in this space.
So is there a reason, Jerry, that the greenhouse gas emissions were the focus of this review? Why that?
That's a really good question, and I guess the simple answer is that feed represents about 50% of the greenhouse gas emissions in pork production. So that's one reason. And manure is the second most important contributor to environmental impacts. And you're right. I mean, there's a lot of other environmental impact indicators that could have been included. But I think, as Nat's going to explain to us, focusing on just one of these, which, by the way, is used throughout entire supply chains, and it's of major importance for downstream customers of U.S. pork, we chose to focus on a single indicator, recognize that we could also do the same thing for lots of other of these environmental impact indicators, but wanted to focus on greenhouse gas emissions as a starting point.
So, Nat, tell us a bit about how your team went about conducting this review.
Yeah, thanks, Sarah. Yeah, so again, Jerry mentioned we wanted to look not just in the U.S. but globally, because a lot of our work has been in the U.S., but we know there's interest in this in a lot of regions around the world, particularly in places like South America, where there's a lot of land use change and deforestation happening. So we did a comprehensive literature review to look and see what studies have been done in the past really 20, 25 years that look at life cycle assessment of soybeans or soybean meal. And so out of the ones that we found that particularly also focused on greenhouse gas emissions, we found 27 databases or studies that looked at soybeans and 22 that looked at soybean meal. And some of them covered multiple countries and some of them looked at one specific place. But you can see we got pretty good coverage in terms of the soybean and soybean meal looked at. And we found that really interesting, and it helped us give more of a comprehensive sense of what's out there. And you can see, in addition to greenhouse gases, I mean, these studies covered a lot of other impact categories, and we're not really going to talk about these, but you can see things like land use change, eutrophication potential, acidification. I mean, these are standard life cycle assessment categories that a lot of these studies did look at, and to Jerry's point, that we could say a lot more about. But again, I think the greenhouse gas story is top of minds of a lot of people and really interesting, and the variability itself important to discuss. So we decided to focus on that.
So going into this review, what was the amount of variation in greenhouse gas emissions that you were thinking you might find when it comes to soybeans and soybean meal? And how did that compare to what you actually did find?
Yeah, well, because of our experience with Foods Cubed, we knew that there would be at least some considerable variation in the literature, and especially since, we would look beyond the US where, places like South America have considerable emissions and variation because of the type of places where soy is being grown. But we really didn't know as well, which is why we were interested, partly because we didn't know who else was working on this and what other approaches they took, particularly on the things that we were thinking about, like, people have, approached measuring land use change differently over the years, different things that they've included. So we just really wanted to get a better understanding of what people were doing where, so we could get a better sense of how we could make improvement within the field in general.
What kind of variation did you find, and what were some of did you determine were the common drivers or the reasons for these differences in life cycle impact when it came to, same crop comparison when it's beans or soybean meal?
Yeah, so, regionally it was pretty interesting. Like I said, a lot of the studies we did find a lot of studies that either looked in the US or places like Argentina and Brazil. For instance, countries in Europe import a lot of their soy from Brazil and Argentina, and of course, they produce a lot of it, and there's a lot of deforestation. So there was a lot of focus there. But even globally, we did find a lot of studies and variation globally. You can see that within the US, we had some counties that were being estimated to actually be carbon sinks, and maximum emissions in certain regions of the US as high as 22 kilograms of CO2 equivalent, which is much higher than a lot of average studies estimate. So the variation was pretty high. And again, we found the same thing in Brazil in a few studies that looked at that. So the variation was high, and I think was interesting because of the reasons behind where that variation came from. And this is, again, doesn't just limited to soybeans, but then in the processing of soybean meal and soybean meal that's sourced out of different regions in these countries.
You mentioned that some variability may be due to methodology choices or maybe even some misalignment. Talk to us about any of those that might have stood out in your work here.
Yeah, so the geographic scale is interesting, right? Because, life cycle assessment as a methodology traditionally has been a little bit more of a top-down approach. Most life cycle assessment measurements are at the national scale. So you'll get an estimate of how much the life cycle impact is of CO2, say in the US versus places like Argentina. But subnational is a lot less common. And once you start getting to that subnational level, you really start to see some of that variation. So at the same time, we did find studies that were field-based. So they did a life cycle assessment for a particular set of fields in a particular country. So that, you could say is really detailed regional estimate. But a lot of these studies, then they just focused on that one subplace. So basically trying to get a comprehensive estimate across all these countries in different places, both at a detailed scale, but a broad scope, we really highlighted the variability that you could get within a country. And I think it was nice to see other folks find the same thing, because that's what we were finding with a lot of our Foods Cubed research that Jerry had previously talked about. Actually, can you go back to the previous slide? There's a few more points I'd like to talk about. Yeah, so in addition to geographic scale, land use change, I think we expected to be important, partly because we found that was an important variable in the US, and indeed it was wherever it was included. And Jerry mentioned methodological choices. This is one where it becomes important because some studies don't even include land use change. And it turns out that how you include land use change estimates and at what detailed resolution and how direct or indirect land use is included can really change that a lot. But either way, it was an important factor in this. Farming practices were very important. The number of studies that actually included differences in farming practices were pretty small, but those that did found things like yield or cover crops or soil carbon storage, things like that really did matter. And so that was really interesting, particularly in places like South America, where again, there's a lot more deforestation, and how and where you're doing that, depending on your land use type, can really vary your life cycle impact. And so those are some of like I guess you could say reasonable variation you would see because of what's actually happening. And then there's also some of these methodological choices, like allocation factors. So for those who aren't familiar with life cycle assessment, when there's a product that is being made into multiple things, you generally have to decide how you're going to allocate that impact to the multiple products. So in the case of soy, when you crush it, right, you create soybean meal, but you also create soybean oil and hulls. And so you have to decide how much of that feed impact goes to feed versus other things, right? And there's different ways to allocate that. And you can allocate it by economic value. You can allocate it by how much it weighs. So there's different ways to do this. And depending on what you choose, you can get quite different impact factors. And what was interesting was not that there was a lot of people that chose different things, but it wasn't always clear what they chose and how, and what those allocation factors actually were. So I think transparency in that realm was something that I think the life cycle assessment community has gotten better with over time, but is not always clear within the data itself. Another interesting technical piece is biogenic carbon. So biogenic carbon is the carbon that is emitted when you have a crop that is turns over from year to year, right? And so you basically have carbon that is sucked out of the air by the crop, but then when it's utilized, it ends up back in the atmosphere, right? So generally, from a life cycle assessment method, biogenic carbon, the advice is not to include in the analysis because it doesn't set the system boundaries quite as broad. Well, we found there was actually a couple studies that didn't do this, and it ended up resulting in some of these negative values that we were talking about before, where it seemed like they were carbon sinks, but in fact they weren't, and it was because of biogenic carbon. So there's some very technical reasons you could get an answer that looks pretty great, like having soybean meal that actually stores carbon. Like, that sounds awesome. But if it's because you're doing the wrong thing with biogenic carbon, it's not telling you the whole story. And things like methods for characterizing impacts, we found that these tended to vary, as well as things like attributional versus consequential LCA approaches. So when you attribute life cycle impacts to a specific practice, most of these studies did that. You generally get a range of positive impact values. If you include how the impact of a particular product uptake could change the use of that product. So if you generally use more soybean meal in the future, that results in a reduction of another type of feed. For instance, you don't have to feed pigs as much of DDGS, maybe if you're feeding them more soy meal. If you include that, you get more feedback effects, and that can also impact your estimates. So studies that did that, we also found provided a lot more variability as well. So again, it's part of this is just being clear about what method you're using and why. It's not that either of those are wrong. It's just understanding where that variability comes from can help you understand what to make of that estimate that is being provided to you.
It seems like there can be a lot of factors at play, that's for sure. So,
for sure.
So Jerry, what value does all of this review? Value does it hold for U.S. livestock producers and feed manufacturers?
Yeah, I think the results of this review remind us that first of all, the use of LCA methodology is here to stay, at least from our perspective. And as we've been explaining, it's used to quantify environmental impacts of not only the feed inputs that go into food animal production, but also the environmental impacts of meat, milk, and egg supply chains. That feed manufacturers have an important role to play in this when sourcing commodity feed inputs and manufacture the feeds that are fed to livestock and poultry, and to help producers minimize their environmental footprint. I think the important thing to realize is that we need to be diligent in questioning the validity and methods. I think, as Nat's pointed out, a lot of the different factors that can go into how these estimates are calculated, and as we check those out, they can be highly variable, and just like we found for soybeans and soybean meal. So we need to be questioning the answers when we're using these estimates, and we've got some upcoming publications that we think are going to hopefully help resolve some of these issues, and particularly for U.S. soybeans and soybean meal.
So then what would you say are your next steps needed or planned when it comes to LCA estimates for soybeans and soybean meal? Are there anything in the works that you guys are working on?
Yeah, so both Nat and I are fortunate to be part of our broader team, and we have finalized actually a couple of studies, one of which I mentioned just a moment ago. We've developed LCA estimates for greenhouse gas emissions of soybeans and soybean meal on a state level using county level data. And we expect this study to be published later on this year. And we think it's going to provide the feed industry with the most current LCA estimates for greenhouse gas emissions by state for U.S. soybeans and soybean meal. We also are building on some of that work by finalizing a related study that's going to provide estimates of greenhouse gas emissions impact of global trade and export of U.S. soybeans and soybean meal, and the environmental impacts of using U.S. soy in producing pork in other countries. So yeah, we're pretty excited. We've been spending a lot of time really kind of drilling down into the details of making sure we get the numbers right for the industry, and they're representative of what's really happening in reality. And so look forward to more stories from us in the future.
Very good. So something for both of you. Any final thoughts or key takeaways, Nat, that you'd like to leave our audience with?
I mean, similar to what Jerry said, I think just be aware and skeptical of as you're using this information, and understand what it's saying, because I think we found that a lot of the results are context dependent, and it's a continually improving space. And I think ultimately the whole goal of this is to try to find ways to improve the sustainability of producing soy meal, right? Like, I think from a Foods Cube perspective, one thing that we try to provide this information to people around the world is so that they can make better decisions, and not just so you can maybe get soy with a less impact, but so you can work with folks and farmers and producers to improve their impact. We work with a lot of upstream buyers of soy and soy embedded in their products, to work with farmers to improve their impact, right? To places where maybe land use change or some of these other factors are really high, and to say, hey, we can do this in a better way to lower everyone's impact. So I think for us, it's trying to use that information to try to improve soy in general, so that soy as an industry becomes more sustainable, and then that helps raise the bar for everyone.
Jerry, same question for you. Any final thoughts or key takeaways that you'd like to leave our audience with today?
No, I think Nat summarized it quite well. I would just maybe make a comment kind of in a broader context, and that is there's a lot of interest, I think, in animal agriculture and connecting animal nutrition and feeding programs with manure and mortality management. And for those in the audience that might be interested, I have the pleasure of moderating a panel of experts during a upcoming feed management symposium that's going to be held in Madison, Wisconsin on July 21st as part of the American Society of Animal Science, Canadian Society of Animal Science meeting. And we're going to be discussing strategies to improve carbon, nitrogen, and phosphorus utilization efficiency in pork production systems during that symposium. So if any of the audience is going to be there, that'd be another great place to get more perspectives on how these things all fit together with environmental sustainability of livestock production.
Something to put on the calendar. Dr. Gerald Shurson and Nat Springer, thank you so much for your time here today. We greatly appreciate you being with us. You're
very welcome.
Yeah, thanks again.
Likewise, we appreciate all of you and our audience for tuning in. Until next time, for Feedstuffs 365, I'm Sarah Muirhead.